I'm going to be showing you about number bases. Now the base, or the radix as some call it, is the number of digits that includes 0 in a number system. So for example, there's the decimal system, which has 10 digits, so that is 0, 1, 2, 3, 4, 5, and etc. You know the drill. Decimal system is mostly common used today, and for example, in the binary system, there would only be 2 digits, 0 and 1. Now, an easy way to remember how many digits are in one base is usually the last digit is 1 less than the base. So for example, 9 would be the largest digit because the base is 10. 1 would be the largest digit because the base is 2. Now I know what you're thinking. What happens to 11, 12, and 13? Well, after base 10, we don't have any digits to use, so we just use letters. So for number 10, you could use A, and for 11, you can use B, and for 12, you can use C, and etc. You know the drill. Now, in number systems, we have place values. So for example, in the number 342, the 3 is in the hundreds place, the 4 is in the tens place, and the 2 is in the ones place. Now, if you want to move places, you can just multiply by 10. So for example, if you want to get from the ones place to the hundreds place, you multiply by 10 to get to the tens place, and then you multiply by 10 again to get to the hundreds place. And I know what you're thinking. What if you have to get from the hundreds place to the ones place? Well, it's that easy. You just vice versa that mess, and you divide by 10 if you want to go backwards. It's that simple. Now, there are 2 ways to change numbers to the binary system from the decimal system. The first way, I call it the equation method. Now, take one number, for example, 13. Now, you'd have to use the binary base system to find all the bases that are either less than or equal to 13, and you would put them in an equation form, thus calling it the equation method. So, you'd use the bases of 2. So, you would keep going until you find a limit. And because 16 is bigger than 13, you found a limit, and that's where you stop. Now, you'd use 8, change that to 8, and then add whatever is left over. But the problem is, all the equation numbers have to be powers of 2. Thus, it's not correct. So, you would do the same thing for the second number. You would keep going until you find a limit. This would be your limit, so you would change it to 8 plus 4 plus 1. Now, all of them are powers of 2, and thus you have just completed your first way of changing a number from the decimal system to an equation in the binary system. Now that you know how to use the equation method to convert a number in the decimal system to the binary system, let's go with an even bigger number, just to challenge you a little bit. Now, I would suggest just listing off your bases and finding a limit. So, looks like we found a limit. Now, you would change that to 64, and we'll let whatever is left over, 50. Now, because 50 isn't in a power of 2, you would change that to 32. And whatever is left over. Same for 18, and you would continue this cycle. It's really simple. Have 16, and whatever is left over. And it looks like 2 is a power of 2. So your final answer would be 64 plus 32 plus 16 plus 2. Voila! Now, before we get into this next method, we're going to have to use place values. But we're not going to use the ones that I showed you before, though they are similar. we're going to use the binary system place values. Now, the binary system place values are pretty much all the same as the other ones, of course. You usually start off with the power of 0, which is 1. So your first place value would always be 1. But instead of going to a 10, you would go with a 2. And remember that list we had before? That pretty much gives you, oops, my bad, that pretty much gives you the place values of all of them. So this is a 1's place, 2's place, messing up, 4's place, 8's place, and the 16's place. And it's pretty much, those are the place values. It's sort of the same with the decimal system. You start off with a 0, which is the 1. Then you keep going, and you have the tens, and you got the hundredths, and then you have the thousands. Even though they're different, they're pretty much the same in a way. Now, the best part about the place values method is that you can start from the equations. Now we're going to go back to our easy 13 example. As you can see, we're going to start from here. And remember those place values, 1, 2, 4, and 8. We have a 1, we have a 4, and we have an 8. But instead of writing those in the place values, you're just going to represent them as 1. So we have 1, 2's, 4's, and 8. So you have 1 1's, 0 2's, 1 4's, and 1 8. And as simple as that seems, that is how you change it to the binary system. And that's your way. And this would be your final answer. Now, to make this a little bit harder, we're going to go back to our 114 example. Now, it's really not that hard. If you already did the equation method, you already have your place values hopefully listed up, and you have your 1's, 2's, 4's, 8's, 16's, 32's, and 64's. You don't need to worry about all this nonsense, and you just look at your final answer. How many 1's do you have? 0. How many 2's do you have? 1. How many 4's do you have? 0. How many 8's do you have? 0. How many 16's do you have? 1. How many 32's do you have? 1. And how many 64's do you have? 1. And that is your final answer. Now, to convert from the binary to the decimal system, you just reverse everything I told you. So let's say you have 64 plus 16 plus 8 plus 8 plus 4 plus 2 plus 1. Now you just add them together. 80, 16, 6, 1. 96, 7, and 103. And then you have a number in the decimal system. Simple as that. Now for the place value system, it would take a lot more steps, but it's almost just as simple. So let's say you have 1, 1, 0, 1, 1, 1, 0, 1, 1, 0, 1. So you just remember your place values and write them out. 1's, 2's, 4's, 8's, 16's, 32's, 64's, 128's, 256's, 512, and 124's. Now, I suggest writing in their equations and looking at the ones you have. You have 124 plus 515 plus 128 plus 64 plus 32 plus 8 plus 4 plus 1. Now, add them together just like before, and you should you should be back at the decimal system. So I'll just do this for fun, why not? This, and then you have this, have this, you have this. Continue to keep adding. Might need to write out this one. Mental math doesn't solve everything, people. $45. And now you have a number back in the decimal system. Just as simple as that. You reverse them. To be honest, converting from the decimal system to the binary system and then vice versa is pretty simple. It's just probably trying to figure out each of these huge powers and base numbers. But if you really think about it, it's not too hard. Now for some fun facts. Before people had all these systems, they used to either count on their fingers or their toes, which I'm not going to show on screen. Sometimes they use beads and pebbles to count numbers. And in some cultures, they were more literate and they began to use symbols to designate each form of counting. There were two ways, the cardinal and the ordinal procedures. The cardinal method involved one symbol representing the number and then using that as many times as possible. For the cardinal system, for example, let's say the system, the number, the symbol, was an and sign, represent the number 1. Now, to count, you would just use that as many times as possible. And that's how you would count your numbers. Now, the ordinal system would have a symbol for each type of whole number, which is kind of like ours, how we have 1 for 1, 2 for 2, 3 for 3, 4 for 4, and 5 for 5. But maybe they had some weird symbol like 1 was an arrow, or maybe 1 was a cloud, or maybe 1 was an and sign, maybe 1 was an at sign, maybe 1 was G. Who knows? Another small fun fact, the decimal system is the oldest known numeral system. It's also the most common, and it's historically related to the Hindu-Arabic numeral system.